A few days ago, Idra released a fairly standard sounding corporate video about their products. But within the half-hour video are some real gems that can help us understand just how impressive their Giga Press is, and why it's helped to propel Tesla to the forefront of auto manufacturing, and what new tricks Idra has up its sleeve for the future. Hey y'all, it's Dr. Know-It-All. So as you might expect, I will put the link to the full half-hour video in the description. It is a quasi-interactive webinar format, so it doesn't have a huge amount of bells and whistles, although it does have a lot of very dramatic music and B-roll and so forth and so on. And by the way, when you watch the clips that I show you, the B-roll stuff, which is the shots of the actual Giga Press and the factory and everything, that's all from Idra and that's part of their video. I'm not putting that over the top. So it's kind of funky because a lot of times they have these weird sound effects going on underneath people just talking about, the amount of weight or something like that the Giga Press is. The idea for this video, by the way, came about because I had at least 6 different people from all over the place ask me about this particular video, so I figured there's got to be some interest in it, and I hope other people feel the same way. Anyway, I'm going to play several short clips that I've picked out, and then I'm going to react to those clips and hopefully help to elucidate some of the more complex or interesting details that they talk about in their video.
Can you explain to us how it is we arrived at the Giga Press?
Well, let me start from 3 years ago. 3 years ago, we reached 100 million euro turnover. We believed that another step forward had to be made. When? In 2017. In fact, we deeply analyzed our product technology and found the potential for good improvements. It was the time to challenge ourselves again, also because the aluminum casting product development trend showed another step towards more sophisticated application of aluminum. It was the full electric car which was strongly pushing for that. We were, let's say, visionaries at the time. We got to the conclusion that the industry will need 3 things. 1, Giga presses for super large amalgamated cast part, but also best-in-class automated production cell with high process stability and efficiency, and sustainable and eco-driven. In other words, we would need a new product line.
So as you can hear from that clip, there's a lot of history involved in this, starting somewhere around 2017, and it sounds somewhat like Idra, and by the way, I'm pronouncing this as Europeans would say, not Idra, which would be the US way of saying it. So anyway, but Idra thought about the fact that they were, I guess, he's talking about being a visionary and thinking about the future, and the fact that larger presses were going to be needed than were currently available. And obviously Tesla uses these presses now. In fact, according to this, and we're going to see this in later clips, the first 2 Giga presses ever manufactured are actually at Tesla right now. They're in the hands of a customer, right? So anyway, but the smaller presses were not going to be adequate for the needs specifically of battery electric vehicle manufacturers. So that's where the kind of inspiration for this came from. It's unclear whether they had been in talks with Tesla originally, or whether they kind of developed this press and then went to Tesla and say, hey, we're developing this thing, would you guys like this, right? So that part is unclear, but very definitely there was a connection between the BEV category, the growing demand for battery electric vehicles, and the need for one of these larger single-piece casting machines.
You are going to see Giga Press number 3 in our shop floor, running full in automatic cycle. For your information, 2 Giga presses have been already shipped and installed at our customer plants, running production batches of the largest casting part ever made worldwide. And now we have an additional 9 Giga presses to be delivered during 2021, and we hope that more orders might come soon.
So as you just heard there, literally Idra has built 2 Giga presses so far, well, 3 Giga presses. 2 of them have been shipped to a customer, and there just so happens to be a Giga Press in Shanghai and a Giga Press in Fremont. So we can pretty much guess where those 2 Giga presses are right now. And they have 9 more, so I assume Giga Press 3, and I know that Tesla has an order for, oh my gosh, I mean, a couple in Berlin, a couple in Fremont, a couple in Shanghai, a couple in Texas. So there's a really good chance that every single Giga Press that that has been made and that is going to be made in the next year are all slated for Tesla, which makes it really difficult for the competition to catch up at all. Even if they had the foresight and the vision and the desire to do these single piece castings, I don't know where they're going to get a Giga Press, because it's not like you can just turn to a catalog and make these. There literally have been 2 of these that have ever been constructed.
A day, the 20th of August. This is the day that I will never forget. The day in which the first batch of good parts have been made, eliminating any skepticism in the mind of the international aluminum foundry community. We decided to have Giga Press in our product portfolio 3 years ago, when nobody thought that it was necessary to have such modern die casting machine. At that time, the largest already designed structural part could be produced using a 4,000 ton. But our thinking was that sooner or later you would have needed a 6,000 ton.
So as you just heard, the original castings, the ones that were the first successful castings, were only August 20th of, I assume, 2020, which means that we're talking about something that's only happened about 6 months-ish ago from when I'm recording this. And that means that not only Idra, but also Tesla was taking a massive chance in terms of the way that they were, you know, gambling on having a machine like this be able to produce something that would actually be effective and create the parts that they're looking for. Immediately after this, they talk about how a 6,000 ton machine, in other words, the size of this thing and I assume that's the pressure of the die casting, or maybe it's the size of the die casting. But anyway, that a 6,000 ton machine allows for a very different way of thinking about constructing a large part.
Giga presses can dramatically change the way the underbody structure of cars and trucks can be made. This new machine offers revolutionary advantages. The lower underbody of the car can now be made in 3 only modules: 1 front casting, the battery case in the middle, and 1 back casting. Let's talk about the investment reduction in foundry shop. If you do not have a Giga Press and utilize the 4,000 ton model, you need 4 die casting machines, each one dedicated to the production of front right and front left, back right and back left. Instead, you can run the same volume by using 2 Giga Presses. And of course, the cost of 2 Giga Presses is lower than the cost of 4,000 die casting machine. Not only that, imagine also the finishing and the assembly line, the implication of having only very few parts. The total investments for the assembling line can also be dramatically reduced. Less assembly stations, less fixtures, but also less robots, less quality checks. Well, I can even imagine that the length of the entire line can be reduced by a good 20%.
So this little tidbit is fascinating. Basically what he's talking about is reducing the car to a front casting, a center casting, and a back casting. And if you think about this, what did Tesla do on Battery Day? They talked about a structural battery compartment, which means that they're looking at now creating a compartment where you can put the batteries inside of an aluminum, you know, chassis or whatever, a tray that you're putting it in basically, and putting that epoxy in the battery compartment and creating a rigid structural component out of that. So this Giga Press actually becomes a part of that particular aspect of building the car. So basically you can build the underbody of the car, not the outside part, the pretty part or whatever, but the parts underneath can be reduced from hundreds of parts down to 3 parts, and that is absolutely amazing. And of course, there's the reduction in the cost that's associated with it. I don't know how much all of these things cost. Since they're such one-off things, you probably have to ask in order to find out how much they cost. But clearly, he says that the 4 die casting machines that you need to build the 4 front and back parts are more expensive than purchasing 2 Giga Presses as opposed to the 4,000 ton machines. So anyway, you've got a massive cost savings. You've got a savings in terms of the components are going to come out the same every single time. And you've got a savings by having to purchase fewer actual moving parts, basically, fewer casting machines.
As a foundry man, I like to say that by putting 1 single piece, you get very accurate and repeatable geometry and better mechanical properties, such as more stiffness than the multi-part solutions. The total energy consumption of the full underbody manufacturing process can be estimated in a good 20% less than the traditional one, which means less CO2 in the air.
So as you can hear, the advantage of building one part is that you get more consistency, you get more stiffness, and you get more better quality control because everything comes out the same every single time. And by the way, Sandy Munro has been beating this drum for a while. So it's interesting to see that, you know, he is very much aligned with what Idra is doing. And in addition, according to Idra at least, it uses 54% of the energy of earlier smaller presses, so it's actually energy efficient and therefore CO2 and carbon emissions efficient as well, which is a big advantage. Of course, this is also, you know, trusting what they're having to say, and I'm sure other competing platforms would have something to say. But anyway, at least that's what Idra says, is that they save quite a bit of carbon and energy, you know, being produced and in terms of utilizing their machines. So then we get to actually looking at the Giga Press itself, which is an amazing and absolutely gigantic beast of a machine. Before we get to that, however, I think what you should know about is kind of what die casting is. If you've ever owned a Hot Wheels car or like a Matchbox car or something, those were like, I remember that as a kid. I would look on the bottom and it would say die cast, and I was like, ooh, cool. It's basically, you take a die, which is a mold, right? So you're taking some sort of shape, which is a hollow cavity in something, and then you're filling it with some sort of liquid, which would be molten metal in this case, and then you're pressing it and cooling it down rapidly to create the actual form. So there's a lot that's going on here. Number one, you have to have a gigantic press, and we'll see the size of this thing in just a second. You have to have this huge press that you can do, and then you have to have very, very careful control of the metallurgy. Doesn't matter so much for like Hot Wheels cars, right? Because they're tiny and it doesn't really matter if they're structurally the best or in weight. In terms of weight, they're the lightest things in the world. But when you get to the aluminum in a car, you want to save every single gram of weight, and you want it to be super stiff, and you want it to be incredibly repeatable. And when you have something that big, the pouring of the material into the press and the actual activity of the press has to happen really, really quickly, because if it doesn't happen that fast, what will happen is you'll end up with like pockets. Like maybe if it doesn't pour in correctly, you'll have like a pocket where no aluminum ended up, or a thinner amount of aluminum, or a larger amount, or something like that. So you have to be able to pour it in a non-turbulent fashion, and then you have to be able to press it very rapidly and remove the heat very, very rapidly from the whole thing. And then of course you have to cycle again, because right, it can't go like that and then take a half an hour to recharge, because then every part takes a half an hour. You're looking at seconds per part, right? It's like kaboom, 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 right? It's got to be able to do it that quickly. So all of this is incredibly complicated technology when you think about something that's multiple meters on a side in terms of size.
The dimension is impressive, isn't it?
Yes, it is, yeah.
It's 19.7 meter long, 7.4 meter wide, and 6 meter high. It is like a house that weighs 430 tons. The cycle time is remarkably shorter than a 4,000 ton anyway.
So obviously, as you just heard from Fiorenzo, this is a gigantic machine, and it operates at a very high speed too. He calls it a sprinter. He says it's agile like a sprinter. You can tell he's very proud. He's the head, I believe, the person who engineered this, you know, at least thought of it himself for the most part. And he calls it his baby. So he's obviously very proud of this gigantic house-size machine. And it really is more or less the dimensions of a house. I mean, kind of a long, skinny house. But anyway, it's incredible, and it weighs many, many tons. I was going to say a ton, but that's way underselling it. So anyway, it's big, it can cast a huge thing at once, and it's very, very fast. And at the heart of it is the 5S, which is the press thing itself.
The 5S is the state of the art at the heart of die casting process. One of the most important, let's say, performance, it is the increasing dynamic force in order to ensuring to fill also the big dies. The new dies arrive also at 2 meters wide or 2 meters square, okay, and the injection we must be sure in order to fill with constant high flow velocity on the molten metal. And this is fundamental to have from the smooth movement of the injection from the very beginning to the end of the stroke. It means that you avoid totally what is related to the turbulence inside the tank. This allowing us to reduce the time to recharge the accumulator. We have to highlight that with this system, we have the same efficiency and the same performance than a standard machine, okay, but with smaller motor and reduce the kilowatt.
So obviously that was a lot of very technical talking, but basically he's reiterating what I was talking about with die casting which is you've got this huge challenge of a 2-meter square die that you have to fill laminarly, which means smoothly. You can't have turbulent flow of this molten metal, and then it's got to push this under high pressure into the shape that it needs to become whatever that, shape of the back of the car or something like that is, and it's got to be able to do it fast, and then it's got to be able to recharge that quickly. So that's the heart of the whole thing, basically, is that they are able to do on a massive scale what is relatively simple to do. Again, with like a Hot Wheels car, those have been around since the 1970s, and those have been die cast for a long time. But those dies are like this big, right? They're just a couple of centimeters on the side. So we're massively expanding the size of this thing, it makes it orders of magnitude more difficult to create laminar flow and get the correct amount of aluminum. And by the way, Tesla has developed its own chemistry so that they've got an aluminum that flows properly under these conditions as well. So it's not just Idra that's doing this, it's also Tesla that's working on the chemistry that's involved in pouring the correct kind of aluminum alloy into this press so that it can all work very, very rapidly and consistently.
Yes, this is the moving platen. Is casted in one piece, of course. Okay, it is more than 3.6 meters squared. Okay, and the weight is around 64 tons.
And then, as you can see, we turn to the actual platen, which is the thing that's the actual die press. It's over 3.5 meters on a side, 64 tons, and forged out of one piece. That is incredible. So the amount of pressure that can put onto the die as it's casting and creating each of these pieces is, I guess, 6 tons, or 6,000 tons, excuse me, since that's the type of machine it is. But that's incredible that it can put that much pressure on. It can be that consistent over that large of a range. And by the way, a 6,000 ton machine is incredible, but I have heard that the Cybertruck might well need an 8,000 ton machine. Or I don't know, because they're using a different methodology, they may just decide to use sheets of stainless steel and bend them as opposed to doing die casting. But we'll have to see, because the underbody of the truck, I mean, they've got an exoskeleton, but there's still going to be some sort of underbody. So anyway, we'll have to see what kind of manufacturing techniques the Cybertruck needs, but it might just need something that's able to bend this steel into shape. But still underneath the battery tray, the structural battery tray that they're going to have to put the batteries in, I would imagine they're going to have to cast that with some sort of machine like the Giga Press. So anyway, they might need a bigger Giga Press, like an 8,000 ton machine as opposed to a 6,000 ton machine. So we'll have to see how that goes in the future. In a moment, let's take a look at Idra's newest invention, the LPF. But first, if you enjoyed this video, please do like and subscribe it so other people can find it, and of course so you can stay informed on other videos. Also, a huge shout out and thank you to my patrons on Patreon. You all are wonderful. Thank you so much for your support. I really do appreciate it. We actually have one new patron since last time, 1Tree7, so great name and thank you for joining us. Of course, don't forget about our merch store, which has Don't Mess with Tesla, All Input is Error, and a bunch of other merch that you can look at. And if you purchase something, it helps support the channel. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how clicking on a link and going shopping helps out the channel. And now let's take a look at LPF, or low pressure forging, which is a new thing that Idra is coming out with. It sounds utterly fascinating. So what they're talking about here is a 2,000 ton press, which is only 1/3 the size of the 6,000 ton die casting machine that they have, the Giga Press, but it works in a very different way, and that's super cool.
The low pressure forging system is utilizing the best of low pressure and of high pressure technology and bringing them together to create a part that is forged and giving us a semi-solid casting technology.
So basically what John is talking about here is that they're kind of blending die casting, which is high pressure, and low pressure systems with forging. And forging, by the way, is that system of like heating up a metal and then cooling it down and heating it up and cooling it down. So that's what forging is. And he's basically saying that they're taking the best of both worlds with this low pressure forging system. And that's super, super interesting.
Strive to differentiate your production by utilizing a new foundry process, our patented LPF, a low-pressure forging process. This technology combines the best of high-pressure die casting, which is the short cycle time, with low-pressure laminar flow feeding of the die, with the aluminum forging process, pressurizing the die cavity when the metal is still semi-solid. This will allow the foundry to make parts with mechanical and metallurgical properties close to that's achievable with the forging process, but with lower production.
So as you can hear, the idea here is to have something that's more metallurgically interesting. In other words, the forging process, and this is what you use for like steel. If you have really, really nice kitchen knives or a samurai sword or a very nice sword, they're forged. And the forging process creates metal with better properties. It makes them stronger, it makes them somewhat more flexible, it just improves the properties of them. And so the idea here is to create a product that allows you to laminarly put in some sort of metal into, it sounds like aluminum is what they're primarily targeting for, but you put that into a low pressure system and then you forge it using a furnace that's underneath this whole system to actually bake the metal, etc., to cause it to get to the correct metallurgical quality. And then the other advantage of this, of course, is that forging is a very, very slow process, and it sounds like what they've done is they've created something that works very, very rapidly instead.
This is a 2,000-ton press. Now, this new machine, the LPF, is actually standing for low pressure forging. Fiore, do you want to explain to us what low pressure forging means?
Well, the machine is similar than a low pressure because you can see a vertical closing, okay, and the vein where is installed a furnace underneath the fixed platen. Yeah. But the big difference are the cycle time and the pressure on the alloy, which is similar to a high pressure die casting. When the vertical hydraulic press has closed the die, the liquid metal is smoothly moved into the mold cavity at the pressure between 0.5 and 1 bar with no turbulence. Then we mechanically plug the feeder tube with an hydraulic plunger so that we can immediately depressurize the furnace. So finally, we can apply very high pressure that can reach up to 1200 bar. When the alloy is inside the cavity, it's still semi-solid, a sort of forging. So in this way, the final solidification takes place with high pressure, minimizing metal porosity, and at the same time increasing heat transfer in the die. So in this way, shortening cycle time to similar standards is normally found, as you know, in high pressure die casting.
So again, we have an awful lot of detail here, but the basic idea is where the two men were standing, there's a furnace underneath there which will heat this entire thing up. And basically you pour a metal in, and then it sounds like what they're doing is evacuating it very rapidly to reduce the temperature. So they're gonna reduce the pressure, which will cool off this metal, which will turn it into a semi-solid kind of slush, like a taffy or something. Except a metal taffy, you definitely wouldn't want to touch that with your hands. But anyway, it will do that, and then it will rapidly increase the pressure and while it's got the furnace running, which will cause the metal to again change. This is all incredibly weird, complex chemistry, very, very cool stuff. But basically it will change the quality of the metal to be like that of forged metal, but as opposed to taking hours or days to make a forged product, it sounds like it will just take seconds. So basically the idea is that you'll have the speed of high pressure die casting with the quality of low pressure forging systems. Will Tesla end up using LPF? That's unclear. They talk specifically about high performance wheels and stuff, so casting those wheels as a single unit. So it is quite possible that Tesla might use it for some of its parts. It doesn't sound like this would be a replacement for any kind of large underbody casting or anything, but it might be really cool for particular elements like wheels or something, or axles or things like that. So as is obvious, Idra's incredible and incredibly huge technology is central to what Tesla is able to do, and it allows them to literally cast their cars in just a few pieces, like a Hot Wheels toy. The cost, time, parts, and energy savings are enormous, and no one is going to be able to catch Tesla without creating parts like this, but it seems like Tesla might have all the 2021 orders already wrapped up, so good luck to everybody else. As for the LPF, we will have to see whether or not Tesla wants this tech too, but it's pretty amazing stuff as well. Idra is, in other words, a low-key, savage Italian company who's helping to change our world. Thanks, Idra. Alright, I hope you found this very technical episode informative and fun and thought-provoking. If you did, definitely remember to like and subscribe, and in the meantime, please do ask me questions in the comments or at my email address, which is drknowitallknows@gmail.com. Till next time, bye-bye.